Okay, so next then for the students in my labs, we're talking about the technical writing, and we're moving on with our sections today. So we've done 2 weeks of the introduction, so we're sort of done with that at the moment. We could go to theory next, but I sort of decided to go to section 3 next, which you can call either methods or experiment. It's your choice, but it's going to tell us now how to do the experiment. So you can see that in this sort of overall template that we come up with here, we've done the introduction. We're going to go on to our next bold category here, which is called experiment or methods. Okay. So it's going to be a rough week because, one, we have to do this writing. It's going to be a different style now on the methods, different philosophy that we get from this section, and there's the figure you have to draw. So I'm going into the week just prepared, okay? This is a joke. We're all working together, and we'll get through it. Okay, but it's going to be a little rough. Okay. So basically in the methods section, you're going to describe how to do the experiment, and you'll have a drawing of your apparatus in there. Some sort of figure. It doesn't have to be a drawing, but some sort of figure, as I'll illustrate here. Okay? So what you're doing mostly in the methods here is you're writing about the equipment and how you used it to get your data. You do not discuss any of your results or analysis in this section here. It is true that the reader should be able to reproduce your experiment and take the exact data you took from what you write. Okay? So you should tell me how I can do your experiment. You definitely want to write a narrative, not a recipe. People do not like to be told what to do. We don't want to see bullet items or enumerated points like 1, do this, 2, do this. So that's sort of the challenge here. It still has to be a narrative that keeps the reader's attention and makes it interesting. There has to be some sort of drawing or figure of the apparatus in there, and your narrative must link to the figure. So there sort of has to be intertwined because the figure is meant to help the person get through your experiment. Okay? So please see there is some online help on the methods section. So just some things to consider as you get going. So please check that out. It's in the same spot in Canvas as the introduction help writing. Okay, so let me talk about the figure now. Figure has to look professional. Please do not take anything off the internet. Do not take anything out of the lab manual, and you have to draw it yourself. This is your interpretation of what you did. Okay. So there's a lot of drawing options. Google Docs is okay, hard. Word can do drawing and PowerPoint can do drawing. So yes, you can do your drawing in a presentation software, but I'm putting a frown face next to all of them because we know what those drawings look like. Okay, an annotated photograph is not a bad option if you don't want to draw or you just don't have any decent drawing software. These don't tend to be decent. And you also investigate something called a block diagram, which does quite well as well. Okay, so the options are like this. Here is your typical PowerPoint, Keynote, Google Doc, or drawing in Word sort of thing. And this looks kind of quick here. In this particular drawing, I'm trying to draw maybe the charge to mass. So I have these might be coils, my Helmholtz coils here. This might be a beam of electrons. This might be a voltmeter, and I might be saying something about the high voltage in there. But generally speaking, it just looks really, really bad. But that's the quick, easy drawing that you can do in some of the drawing software. But I'm just saying it just never looks all that great. The better thing to do, and I definitely don't expect any of you to do this, is to use some technical drawing software like CAD or something like that, where you can get very precise scientific apparatus to look coming out here. This is what you find in publications typically, but what CAD does, of course, it allows you to have sort of the dimensions and perspective are sort of all taken care of for you. Here's the perspective alignment and so on. It's taken care of for you, so they're nice to use in that regard, but they have a very steep learning curve. So if you want to investigate using some CAD software, I would say go for it, but not a requirement. The other thing you can do is sort of annotate a picture, but it sort of has to be your picture and it has to be a bit staged. And let me tell you what I mean by that. So this is how you might advertise your apartment for rent or your house for sale here. You might have a picture of a room here, and you might tell people that it's furnished. So you might say, well, you get a lamp and a chair and a table, and that's fine. Generally, you can see what's going on here. But of course, this isn't a very good picture here because the apartment's so messy, and so you wouldn't want your experiment to look messy either when you try to present it to someone in a report. So you definitely want to label the lamp, the chair, and the table, but you might want your experiment to look nice and neat. And this is what I mean by sometimes your experiment has to be staged, okay? And I take that word from sort of the real estate market, is you stage a room before you present it to, say, buyers and things like that. You put pillows and furniture and things you would probably never use yourself, but it just makes it look nice, okay? You have to stage your experiment a little bit, okay? So here's an example of a charge to mass ratio experiment that, it's okay. It's a little messy with the wires and things like that, but it's an image that I took. And you have to be a bit careful with your photo because we don't want any real fun in our experimental photos here. So we just don't want you in there. We don't want your hand or leg. We don't want your friend in there. We don't want you having your arms around anyone. So you have to be a little bit careful with your photo in terms of staging it, is that it just shouldn't look too casual. Okay, this is probably a bit overboard here, but you get what I mean. Okay, we also don't want you in your figure. So this is you tired coming out of the quantum lab in front of the computer maybe you took data with. You just really shouldn't have yourself in the figure, ever. Okay, and so here's something that you could do. You could have, say, label this the high voltage over here. You could label this the current heater. You could label this the magnetic field switch, all that sort of thing. This looks pretty nice, and so the reader gets a general idea about how equipment was placed and hooked up. The problem with these figures is there still might be some issues about how the wiring actually worked. Like, I don't really know from this figure where these red wires are going if I was trying to get this to work myself, so that could be a problem. This is actually a figure I took out of a published paper to show you, and you see that this is definitely staged. There's no way that anyone's experiment is going to look this neat, but it definitely gives me an idea of what the author of the paper did in terms of the experiment here. And here's another one right here, and so we're being a little casual maybe with the hand, but on the other hand, there was a hand adjustment in this experiment, and also I think the pliers here in the hand give a sense of scale to the person looking at the figure, so you sort of have that in there. Okay, so these are just annotated pictures that worked and got published. Okay, the block diagram are probably going to be the most popular given this virtual world that we're in, also because it just allows you to tell me the interconnects between devices, but not the formal ones here. Like, for example, not formal connects. Like, there's only one line or wire in here. Like, I know high voltage would have two wires coming out of it, right? The red and the black, but in terms of the logic, the high voltage is connected to the heater. That's all this line tells me here. So the high voltage goes to the heater. That's all I need to know. And then the heating current is connected to the heater, and the ammeter is connected to the Helmholtz coils, and the current source goes into the ammeter. That kind of thing just tells me the logical layout here, and these are the coils here, something like that. This works okay too. Tells me how things should be laid out. Okay, so whatever you do with your figure, then make it good. Okay, put a little time into it, but not a lot of time. Okay, I know that we're doing this on a week-to-week basis, so I don't want anyone spending 60 hours on a figure, but I don't think it takes that long to make something look nice. Okay, these rushed and quick drawings are really easy to spot. They're not going to do well. Please don't do anything funny or anything cartoonish, nothing hand-drawn, anything like that. All parts of your figure must somehow be tied to the writing at some point, and don't just say things, loosely speaking, like our apparatus is shown in the figure. That puts too much work on the reader to figure things out. Don't just dump us into your figure like that and expect us to be able to figure it out. And your writing just must make use of the figure. So you might even draw your figure first so that you can write around your figure. So I think your figure in this mode here, the figure for the methods section, I would say, is very much like the plot for your data section, which we haven't done yet, but it's sort of a central feature there that you might write around. Okay, so just a couple hints here. I encourage you to look at that document online here, but find consistent terminology. Okay, like if you have a peak, don't call it peak in one paragraph and spike in another, that sort of thing. And be careful with the casual words. Things like energize and things mean things in physics, so be careful what the way you describe things. It's okay to sound boring. We're not trying to entertain anyone. Just like a robot is fine. Just tell us about your equipment and what you did with it. Don't try to entertain us. But don't bore us to death either. But it's okay to be a bit boring in this sort of writing here. Watch very long sentences of instructions. Okay, no one's able to follow those. I can't. You probably can't either. So break out those long sentences. Don't get too lost in your goal. Remember, stay on focus here. We're trying to tell us how to do your experiment. And also, I'll say watch this sort of the big word density. Like if you're writing about experiment involving charged oil drops. If you see charged oil drops, say in every sequential sentence, charged oil drop this, charged oil drop that, charged oil drop this, it just sounds too much, too repetitive. So watch the big words. It's just going to require practice once again, and then of course the figure should be in there too. Okay, so fully describe the apparatus, how you took your data. It is not a written list in step-by-step format, but a complete stranger should be able to reproduce your apparatus, reconstruct your apparatus, and take the same data you did. So it's not a step-by-step recipe. It still has to be a readable narrative. And I think that's sort of the challenge here in writing this section. Okay, and so some of the other examples of figures that I've seen from students in the past. Here's a few here. Here's a nice annotated one here of the Millikan oil drop, which we don't do anymore. See nicely offset numbers you can easily refer to. Here's a pretty decent sketch. Using some drawing software, I don't know, but it came out and looked just fine. Here's a block diagram, and here's someone who went into a tad bit more detail to even say what's even between, the plates in this case of the Millikan oil drop. So these are all pretty nice figures from students here. oops, I'm losing my pencil here, that you could probably shoot for yourself. Okay? And so that's all I have for you for the work for this week.